Hello and welcome to a demonstration of the new MultiHeight time-queryable WRG objects that have just been introduced into Openwind. So these are like regular WRG objects in that we use them to model speedups across the site relative to the mass locations. But instead of just being one static fixed height object, we now let them be at multiple heights, and we also allow them to have different layers for different times of the year or times of day. Okay, so the first thing we want to do is bring in some WRGs. What you can see here is that we've got a bunch of different WRGs at different heights. If I go new layer, folder layer, I can then move all these across, and now if I right click on this layer, I can say create multi-dimensional WRG. And what we want to do is we've got different WRGs at different heights, so we want to combine them into one multi-height object. So if I say height, you can see that it pulls out the heights from WRG, and we don't need to worry about the order. The software will sort that out, so I can just press OK. Okay, so what you can see now is that we have one WRG object, which I'm going to call annual, and then for each of these we have for each of the heights in there, we have a mean wind speed, which you can see kind of is very much affected by the terrain on the lower levels, and then smooths out as you would expect as you get much higher up, so 160 meters above ground level, and we're really starting to do less and less of that effective terrain. Okay. So this can be used, we can do an adjust to mast using multi-height mast objects, as long as we've got at least the same range of heights in the met mast as we have in the WRG. But we can combine these multi-height WRG objects together to form time-queryable multi-height WRG objects. So the next thing I want to do is to bring in some more WRGs. Before I do that, I'm going to go into preferences and just switch off these display layers, because we aren't interested in seeing them just yet. Okay, so I have WRGs for summer, which I'm going to put into a folder and name it summer, just so I don't forget. And I'm also going to create a folder for winter and bring in my last set of WRGs. Okay, so I just need to go through the same step as we did for annual, for summer and winter. So create multidimensional WRG by height. Okay, call it summer. And same for winter. Okay, and now we're going to combine these multi-height WRG objects into one big time-queryable WRG. Okay. So again, I right-click on the folder, go to create multidimensional WRG, and this time I'm going to say for the summer one, let's say April to September. Okay, so that means that if we ask the WRG for speedups and we give it a time or a date time object, then it will give us a speed up based on on the layer that fits that date time object. So in this case, any date and time which is between the start of April and the end of September. For winter, we're going to say January to March, and then I'm going to add another time query object and say from October to December. And you can have as many of these time query objects as you like for a single WRG layer. Okay, and then annual is going to act as my fallback, so all days, all hours. And in terms of doing a time series WRG, it's not really necessary to have that fallback. I could have used winter as a fallback, but the nice thing about doing it this way is that this compound WRG object is going to give us seasonal specific speed ups when we're doing a time series energy capture. But if we're doing what we normally call a tab-based or statistical energy capture, then it will use the annual fallback WRG because we're effectively not using the time element, so it just indexes into the overall average. Okay. So now if we go back into preferences and re-enable some of these layers, we can go in and say recreate display layers. And now we have average wind speed by height and time query, and the last one should always be the all days, all hours. And you can see then as we go up, like we looked at before, it kind of smooths out as we go up the column. We can also compare the average speeds for summer and winter, and then the overall. And then like this version here is queryable then by height, direction and case. So we can go through different directions, different heights, and look at different cases. And when we do an adjust to mast on this kind of object, again we need the mast to have multi-heights, at least the same height range as the WRG. But then what will happen is it will adjust the fallback layer using all the data in the mast, but for the summer WRG layer, so for this case, it's just going to use the summer data. So it's going to look at the MetMast data and it's going to filter it by the same time query that we put into the WRG. And the same for the winter data. So effectively then we can do an adjust to mast where we're adjusting to the real data, but we're also adjusting to subsets of the data based on the time queries in the WRG. Okay, hopefully this is the start of a lot more flexibility in the way that we model projects and trying to incorporate the time element back into the energy capture process. Thanks for your attention.